All right, before we continue on, I wanted to briefly go over ionic equations. And I think this is best expressed by doing kind of a compare and contrast. So let's first start out with our classic molecular equation. And a molecular equation is the standard way that I've been writing equations. So each compound, and I'm going to abbreviate compound, is represented by its formula. This is kind of the standard way of writing chemical reactions. So let's just take an example equation, and let's do one that we did in our previous video where I said you could take sodium hydroxide, that's our drain cleaner, and it's aqueous, and we could mix this together with hydrochloric acid, which is aqueous. And we said when we do this, we're going to make salt water, NaCl, and this is aqueous, and we're going to make liquid water. And just remember that AQ symbol means that the sodium hydroxide isn't in its solid form, it's been dissolved. So dissolved in water. All right, so this is the classic way of writing out all of these. Okay, but let's take a look at the total ionic equation. And the total ionic equation basically breaks things down. So imagine this. Imagine that soluble ion pairs are broken up and shown separately. We'll talk about which ones are soluble and not later on. So soluble ion pairs are broken up and shown separately. All right, so let's get a little bit of a space here so we've got some room to separate all these out. So let's imagine the top reaction, and we're going to break it down just one by one. So let's focus in on this. So sodium hydroxide is an ion pair, and specifically it's made up of sodium cations. And so this, when it's dissolved in water, is just going to be aqueous. And it's made up of hydroxide anions. Again, this is going to be aqueous. All right, so now let's go to the next one. We basically said we've broken these apart. Let's break the HCl apart. Okay, so if we do that, we're going to end up with H+, these are just protons, and that again is going to be aqueous, and then chlorine, when it's ionic, will be negative, and again, this will be aqueous. So now we've broken up all of our reagents into their respective ions. Some textbooks get a little bit picky. I'm a little bit picky too. H+ doesn't actually exist in solution, but let's just assume that it does here. It'll make our lives a lot easier. Okay, so we've broken everything down on our reactant side. Now let's do our product side. Okay, let's do the NaCl. So same idea, we get Na+, would be aqueous, and chloride, which is Cl-, again would be aqueous. Okay, so we're almost there. And then if we look over here, this is not an ion, right? So we'd leave it as is. So not an ion pair. Okay, because of that, we're just going to leave this as plain old H2O as a liquid. So now we've got our total ionic equation. But like I said, anything that's not an ion, meaning it's 100% covalent bonds, like water, we want to leave it exactly as is. Okay, this brings me to my next point. Okay, and this next point is that ions that are present on both sides meaning they're present in the reactants and products, they're not really doing anything. Therefore, they are called spectator ions. It's kind of like going to a soccer match and sitting in the stands. You're not actually participating in the game, but you're there, right? So you're a spectator just like these ions are spectators. They're there, but they're not participating in the actual business of the chemical reaction. Okay, so let's go ahead and use the magic of this. And I'm going to just copy this because we're going to use this a little later. So I'll just go copy. And this leads me to my next point, is the net ionic equation. And with the net ionic equation, we're basically asking, all right, spectator ions don't really do anything. So let's just focus in on what's actually changing during the reaction. So I'll just write exclude spectator ions. All right, so let's just copy this down. That way we don't spend a lot of time redoing it. And let's try to identify our spectator ions, right? So over here, I would say, well, sodium is present on the left-hand side and it's present on the right-hand side. So I'm just going to go ahead and cross these out as spectators, right? And then I would look for hydroxide. Well, there's hydroxide here, but it doesn't look like there's a hydroxide on that side. So I'm going to leave it. And then next, I've got H plus here, but no H plus over here. So I'm going to leave it. Okay, and then I would go over here and I'd say, chloride, looks like I've got those on both sides. So those are just going to be considered spectators, right? So that means the net equation is going to be OH minus aqueous plus H plus aqueous goes to H2O liquid. This is the main emphasis of the chemical reaction, excluding all of the spectator ions. All right, I hope that clarifies those points. I think it's best expressed by breaking it down kind of like I did. But if you find any other tips and tricks on the internet, you're welcome to use those as well. All right, good luck studying.